Okay, this is going to be just a discussion about research in this area of cancer, all the different diseases. Every disease there is, literally, is an invasion. What invades? What is supposed to stop it from invading? Let's talk about the chemistry of life. I took all this at Johns Hopkins Genomics, and I went to Rice for chemistry, and I've taken courses everywhere. And it's just what I do. I like it. I'm a researcher. And this is strictly research. I'm not telling you to do anything, not do anything. All right? I'm going to show you how the digestive system in the body works and what it needs to be able to digest. What is the chemistry going on? That's what it's all about, is chemistry. Here we go. All right. Literally all diseases are an invasion of your protective tissues into your vital tissues. All right. And what are protective tissues? They're membranes. This is a membrane. This is cancer. Now, cancer is an invasive disease, but it also makes growth. It grows by getting into your really vital area and then feeding off that, and it grows big. So these are cancer growth of cancer. Now, it has to get past this layer right here. And they didn't really even realize this until just recently about this particular layer. And I am not kidding you. Watch this. Okay, here's the deal. I'm going to show you, this is considered a new organ now, and all it is this layer and all these fluid-filled highways, and I'll show you that in a second. These are biphosphid layer membranes. There's two layers, and inside there's a wet matrix, which has all of your enzymes. This is what they missed, was the enzymes and the bacteria living in there. They think that they got to kill all these bacteria because they invade you. And yes, in some cases that's true, but there's always a balance of bacteria. There's good and bad. You have to have both of them. You absolutely have to have both of them in you, or one will take over and become dominant, and then you have a problem. They have to balance each other off. They send in the correct bacteria at the right time, related to how your immune system sees what's coming into you. And I can show you a video. They've seen this happen. All right, wait till you hear this. Before I read you the text, don't forget, this is the new organ that they just discovered. Meet your interstitium, newfound organ. Here's where all of that activity was going on, right in this immune cell area. And then they send out these killer bacteria with enzymes to go attack things. This is the fluid-filled highway. They never knew this was here before. This is brand new research back to 2018. I knew about this years ago because of the research I do with other things. I'll just leave it at that. But all of these little balls and all of these little cavities here, these are the immune cell housings that house all the bacteria and so forth. Those are basically a part of the plasma membrane. Everything has a membrane. All that is a membrane. All right, so that's basically a membrane. It's protecting here from out here. That's all it does. It's a separation zone. Now, so this cancer has penetrated this membrane. It starts growing down here. All right, so it's eating away at all this stuff. Now, some guy's supposed to come along here and say, no, you can't come through here, and they're all dead. There's nobody there to stop it. So it keeps going. Now, if you can't replace the bacteria, it's just going to pop up in another place and another place, because that bacteria has to be surrounding that organ. Because every organ has different chemistry. So the different chemistry has different types of bacteria. That's why you have different colored bacteria. And I mean, there's thousands and thousands of bacteria. And the bacteria are the only way you get an enzyme. Now we're going to get a little deep. Because if you don't have the bacteria, you're done. It's case closed for you, my friend. All right, this is the first time they've ever seen this. This is from Seeker. It's called Your Textbooks Are Wrong. This is what cells actually look like. This is an immune cell. This is a bacterium who's scooping up all these little enzymes, going to take it out through this membrane wall and deliver it through the fluid-filled highway to kill something. They never knew this before. All right, he explains there's one type of bacteria that they can see swishing around in here and trying to figure out what's going on in the environment. And then it reports back to the other one that is grabbing a hold of all the different enzymes and going out through the fluid-filled highway. You see that one? That one scooped up all the stuff it needed. It's headed out into the highway. So don't forget, this is just recently discovered that this is where this transport happens of these enzymes and bacteria. Before, how would you get a bacteria from your gut up to your eyeball? I mean, almost instantly they can travel through this. I mean, the flagellas spin a bazillion miles an hour, and they really move quick. And they were in these immune cells, grabbing up what they need to get out here. But the key with this is the chemistry. Here's the key. All right, this is from a chemical enzyme purification company, and they do clear water and so forth. Now, what are bacteria, enzymes, and chemicals? They're three different sort of things, but they all come from the bacteria. All right, so what happens here? Bacteria are the living cells. They're single-cell creatures. Here they are right here. All right, I'm going to walk you right through this. This is a bacteria. Single cell, that's one cell. I mean, it's just tiny. And it's just a living little creature. It has a flagellum that spins like a propeller, a rocket ship in that through your body in that fluid-filled highway. It has DNA just like every living creature is, and that's a living single-celled creature. And then it creates these ribosomes. The ribosomes are the things that we're interested in. Those are the enzymes. Now let's continue on. All right, so you just saw they're living cells. Now that living cell consumes something. It consumes wastes of different types. All right, so it goes around eating up wastes that are in your body. They got to be cleaned up, otherwise you get lymph cancer, you get melanoma, which is just buildup of trash that you can't get rid of, and then it gets toxic. And that's what the research indicates. And again, this is strictly research. Now, so the bacteria are living cells, but they consume things. That's one of their jobs. They can reproduce by themselves. And once they start living in there, you're good to go. And actually produce enzymes. Better said, bacteria are factories that produce enzymes. If you don't have the bacteria, you don't have a factory. You don't have a factory, you can't make a car. You don't have a factory, you can't make a computer. You need the factory, which is the bacteria. So the bacteria is dead, you don't have the factory to produce the enzyme. Well, the enzyme, where do I show you what the enzyme do? Or maybe I have shown you, but they are, it's just so unbelievable, it's hard to even believe it, because it's unbelievable. But it's true. When the right bacteria are present in the right quantities, in the right conditions, in the right chemistry, they produce enzymes much more economically than people can manufacture them. People try to make enzymes, which are invasive little molecules, basically, and I'll show you how they're called catalysts. Now, enzymes are not alive. They're chemistry, basically. They're complex chemicals produced by bacteria, and I mean they're complex. When I show you, knock your socks off. They cannot reproduce. They can't, but they can go over and take over things, and they can consume wastes. They can break down other things. They speed up chemical reactions without getting used up themselves. They come up and they go click, and everything just gets whacked one shot. Click, everything gets whacked, and it just keeps going around your body until it gets rid of all the bad stuff. Now, listen to this. However, enzymes are all proteins. Remember this, enzymes, which does all this chemistry instantaneously, are all proteins. Some enzymes attack other proteins. That's why you have good proteins attacking the bad proteins back and forth, and you get a balance going on. Therefore, enzymes' usefulness is limited by digestion from other enzymes. They work in harmony with each other. If you take something that kills your enzymes, I mean your bacteria, you don't have the enzyme. You can't. Then you're going to be all kinds of issues. I mean, literally all disease that I can determine is an invasion of chemistry because of the bacteria. Because of these molecules are so elegant. I show you how elegant this is. There is nothing more elegant on the face of the planet. And every bacteria has one specific job, to make one specific enzyme. All right, I'm just lead you right through this. That's the single-celled bacteria that lives in those cells, in the immune cells, and that little bugger is one cell. It goes out, collects up, and delivers these ribosomes. And it goes through the fluid-filled highway, and you know where that fluid-filled highway is right there. And this is the coating of your skin, the coating of your organs, and that's the membrane that protects you from invasion. If you don't have the right chemistry in there, it can't fight back. Now, what does that chemistry do when it fights back? Well, here's what happens. Remember we talked about ribosomes? Well, here's a ribosome. It's coming out of there, one of those little balls. And it has a sheath around it. The sheath opens up and it creates an enzyme. Enzymes are proteins. Remember we talked about this. Enzymes are proteins. Now, what does that enzyme look like? Well, get ready, because here it comes. That's what that enzyme looks like. Same, it's going to be exact same enzyme every single time. It won't be any different whatsoever. And when it comes out in a ball. When the sheath comes out of the ball, it does all this stuff and it creates this. And it goes, that's it, done, I'm done. All the magnetic zones are here. And when it comes up to click against an invader, which has been signaled by that bacteria that goes out sniffing around, it says, hey, there's a guy out there. Okay, I'll go get him. Beep, done, case closed. Ain't any other guys around here? Well, I saw one down the road here. Boop, done. That's what being immune is. But if you don't have the chemistry, you can't do it. And you don't have the bacteria, you will not have the chemistry. Because the chemistry is the enzyme. Now, what does the enzyme do? Listen to this. Whoop, hold on. Okay, this should be fully well understood. These are the role of enzymes as biological catalysts. And a catalyst makes things accelerate. This is from the National Library of Medicine. Catalysts make things happen just instantaneously. It would take literally hundreds of years. Now listen to this. A fundamental task of proteins, which are these ribosomes, are to act as enzymes. They're the enzymes. The catalysts increase the rate of virtually all chemical reactions within cells. Now listen to this. Enzymes accelerate the rates of such reactions by well over 1,000,000-fold. So reactions that would take years in the absence of catalysts can occur in fractions of seconds if catalyzed by the appropriate enzyme. Now, cells contain thousands of different enzymes, and their activities determine which of the many possible chemical reactions will actually take place within the cell. They all work together to create this exotic chemistry. And that is the role of enzymes, is to work as a catalyst. And they don't even get used up themselves. I think I explained this. They're click chemistry, they call it. Click! And it's just like shooting a lightning bolt through everything instantaneously. They're all gone. Instantaneously, it changes the molecular configuration, the magnetic configuration of all these other molecules. Because if you change the magnetic configuration of the enzyme, you just destroyed it. That's what happens when you overheat things. They change their molecular structure. And then they become, what do we call it? I can't remember. Well, they don't work. Denatured. Which means they don't work anymore. Their nature doesn't happen. They're denatured. But this happens from heat. So don't forget, that's what we're dealing with here. That's an enzyme, which is a protein. And that goes roaming through the body, through that fluid-filled highway, and bang, it is something. All of these are, every one of these little dots at the end is a magnetic signature. And it has to be literally identical to that every single time, or it doesn't work. It won't work. And that's what the bacteria is there to do, is to make each one of these. And there's thousands, like they said, there's thousands of different bacteria which create thousands of different enzymes. Many thousands. And they roam through that fluid-filled highway. Now, I was going to get real deep into this, but people get lost after a while. But the key to cancer and any invasive disease, anyone, is penetrating these membranes. That's the membrane right there. If you get past that, you're done. So if you don't have your chemistry going here, I think I showed enough to really cover my bases, but this is where all the chemistry starts in your body, basically. It all happens mostly in the gut, because this is where all the nasty stuff is that can attack you, and you have to attack it to break it down, to absorb it through these different layers of, you know, you have your small intestine, your large intestine, your colon, and everything. And you see these secretory glands, they have the shooting in enzymes. That's what they do. Every one of your organs creates enzymes. Now look at here, this is bone cancer. Why would that happen? There's a membrane around your bone, just like as everything else. And that membrane is destroyed, and the bacteria has a place it can grow, because the membranes, there's no coating on it anymore. It's like it's not covered anymore with anything, so they just take up residence, grow all those crystals. It's basically this type of thing. There's nothing here to say don't come through, and it says, okay, I'm coming down to get some nourishment, and I'm going to start growing here. And then they have the crystals, or they have big lumps, or all kinds of things grow from cancer. You have tumors. That's what it's all about. They finally found a place they could get down to be nourished. So you got to keep that membrane good. All right, so what do we need? We need a bacterial database, and we want to know who has what conditions and what bacteria is in their body. That's all. As simple as that. And you can do it primarily with a fecal swab, because all of that bacteria, almost entirely, is developed inside your intestinal areas and your digestive system. That's where all that bacteria invades food coming down to break it all down. It runs through all this fluid-filled highway. You got all kinds of different enzymes created by different organs. Saliva, pancreas, gallbladder, all that stuff. They're squirting in juices to dissolve certain things because they're enzymes. And the enzymes are created by the bacteria that's living there. So you may not just have one enzyme shooted in there. Well, I can guarantee you don't just have one. You have thousands of different enzymes in each one of these organs. And they work together in concert to break down molecules instantaneously. That's why a catalyst can work. You have to be able to have access to all of that different chemistry to done. That's how fast it works. Years worth of chemistry in a fraction of a second, and it doesn't even get used up when it does it. It's the most elegant thing. I mean, I'm just blown away every day as I keep studying deeper and deeper. But I can tell you one thing right now: if you don't have the right bacteria in the right quantities to do the job, to create the enzymes, and the enzymes are the chemistry, your body won't function correctly. And that's what chronic diseases are. And that's why you usually have, you know, an invasion of a certain organ. They'll call it colon cancer, rectal cancer, you know, esophageal cancer, lung cancer. That's exactly what happens. That particular membrane just can't withstand the attack. All right, I'm just probably leave it with this. But they're talking about the colon might not seem very important in the digestive process. It's just where everything dumps out of. However, it is very important in the production of vitamins because of its absorption, because of the large amount of bacterial flora. You have to have the right bacteria there, and to its reabsorption of fluids. So every piece of your digestive system has its own reason for being there, and it has to have a certain amount of bacterial flora living in there to make the chemistry, to make that specific layer work. The layer's not there just for nothing. The layer is there and has to be maintained, and it has to be protected. That's what membranes are about. There's a membrane between every one of these. This isn't just one big membrane. There's every one of these layers, and there's membranes, and a lot of membranes between each one of these layers. It's all one huge amount of lamination that surrounds everything in your body. They call it tunica, subserosa, all of these different things. It's really fascinating, to be perfectly honest with you.